So let me just try and explain that as best I can in the time frame. Now let's supposing we got 4 fields. This is the same example I've used in previous slides. All the fields I'm reporting have got the same 1p, 2p, 3p volumes, which I've extracted from my density functions that I calculated. And they've all got a mean of, you can see there, I've shown you the distributions behind the numbers that I've extracted those values from. What I want to get to is I want to total it up. But as I say, you cannot just add arithmetically. So if you added all the 1p, all the P90 numbers, to a total P90, that's no longer the 90% confidence level, okay? Or the 50% or the 10%. Because you're adding probability distributions, not single deterministic values. So let me try and show you what happens or what the difference is. Because it makes a big, big difference. So here's the result of adding them all up using the same Monte Carlo simulation package. This is the total probability density function for the total reserves in that company. In the pink boxes at the bottom, by definition, if there's 4 fields, their minimum reserves was always 20 million barrels. So the minimum reserves for the company must be 80, 4 times 20. I can do that quite quickly. The maximum reserves in each field is 400. If we've got 4 fields, then the maximum reserves the company could have, again, would be 1,600. There's probability density function. What's the chance of getting 1,600 million barrels? Well, it's so small I didn't even bother plotting it on the x-axis. Okay? What is telling me the shape of the distribution is, and I've extracted the P90, P50, P10 for the company now, not the individual fields. I've got a 90% confidence of 263, 50% of 381, and P10 of 558. I don't know how many mathematicians are in the audience, but someone in the audience will immediately say, oh, well, this is a product of what's called central limit theorem. The more distributions you add together, the tighter the distribution gets with time. Okay? And the more, as I would say, normal it becomes, more symmetrical it becomes. Okay? This is only 4 fields, so it still looks skewed. You do 10, 12, 15 fields, and it'll look very symmetrical and very tight. Numbers in blue are just the answers if you just added up the individual 1p numbers, the individual 2p numbers, the individual 3p numbers. And you can see that 196 is very different to 263. Okay? So having told you that what the correct way to do is you should use those green numbers, not the blue, what does PRMS tell us to do? Well, PRMS is obviously someone in the SPE committee said, look, we've spent so much time trying to explain how to do probabilistic addition, and we always fail to get it right. Let's just add them up arithmetically, because we're sick and tired of accountants and lawyers ringing you up at the meeting and saying, your table doesn't add up. Okay? So the real numbers should be in red, the arithmetic additions are in blue. So in the PRMS it says, look, we know it's not right, but beyond the field level, just add them up arithmetically. It makes our life a lot easier. But what we do in a good report would actually put a footnote to the table, which effectively says if you sum the individual 1p numbers, that's a pessimistic outcome. The real 1p is much higher. Equally well, the sum of the 3p's is optimistic. The real 3p is going to be less. So internally in a company, if I was doing internal sort of strategy work, I'd work on the red numbers, because that's what I really believe. But for statutory reporting, okay, I use the blue. Okay, so having spent all this time telling you to do it properly, I've just now told you to forget it all. All right, but you need to understand the underlying principle behind the numbers. Now I'm going to go on and show you a case where you would not do that, and to